Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a look at our first examples in solving rational equations. So rational equations are going to be equations that involve rational functions or fraction functions. So when we solve these, because we can have variables in the denominator, it's going to be important that before we get to solving, we look for excluded values. We know that we are not allowed to divide by 0, so any x value that would make any denominator in the function 0 is going to be excluded as a possible solution. So we should start each and every one of these problems by listing our excluded values. So here, taking a look at 1 divided by x equals 2 divided by 5, I'm going to take a look at my two denominators. One I have x, and the other I have 5. Now 5 certainly cannot be equal to 0, but x can, and the value of x that makes x be 0 is 0. So we're going to note that one of our excluded values is x equals 0. That means it is excluded, it cannot be one of our solutions. So we're just going to jot that down and come back to that at the end. Okay, so now we want to know, how do we go about solving this? Well, it's actually going to be quite similar to when we work with fractions and equations in general. We want to get rid of the fractions. So we would do that by multiplying by our least common denominator, or LCD. Now, our least common denominator is often found in these rational functions by taking the product of our two denominators. So in this case, x times 5, or 5x. That's going to be our least common denominator. So we're going to go ahead and we're going to multiply both sides of our equal sign by 5x, or we can think of it as 5x over 1. All right, now we'll go ahead and actually multiply on both sides, simplifying as we go. So on this side, I notice that I have an x in the numerator and an x in the denominator, so those are going to cancel out. And that leaves me with 5 times 1 over 1, or just 5. On my right-hand side, I have a factor of 5 in the numerator and in the denominator, so that leaves me with 2 times x over 1, or just 2x. So after multiplying by our least common denominator, we now just have a linear equation that we can solve. So solving here, we'll divide both sides by 2 and get that our solution is x equals 5 over 2. Now remember though, we did have excluded values, so we need to get in the habit of making sure that our proposed solution was not listed in our excluded values. In this equation, our only value that was excluded was 0, and 5 over 2 is different than 0. So x equals 5 over 2 is our answer. Okay, let's try that again. So here's our new equation, 5 over x equals 7 over x minus 4. We always want to start out by listing our excluded values, so taking each and every denominator and asking what would make it 0. So 5 over x, our denominator there is x, and the value that would make that 0 is 0. Taking our second denominator, our x minus 4, the value of x that would make that 0 is 4, because 4 minus 4 is 0. So x equals 0 and x equals 4 are both excluded as possible solutions. Now that we have that down, let's go ahead and figure out our least common denominator. So in this case, that least common denominator is going to come from, again, the product of our two denominators, x times x minus 4. So I'm going to go ahead and multiply both sides times x minus 4. And you can think of those as over 1 if you like. Simplifying here on the left, I have a factor of x in the top and a factor of x in the bottom. So what I'm left with is 5 times x minus 4. equals, on the right-hand side, I have a factor of x minus 4 in my numerator and my denominator. So what I'm left with is 7x. Now once again, I have a linear equation, so I'm going to go ahead and work to solve that. First step is going to be to distribute my 5, so that's going to be 5x minus 20 equals 7x. Subtracting 5x to gather all my x's onto one side, I have negative 20 equals 2x. Dividing by 2, I get that negative 10 equals x. Before we box that up, go ahead and check it against our excluded values. The only excluded values we had were 0 and 4, so negative 10 is a solution. All right, one more in this video. Checking out x plus 3 over x plus 1 equals 15 over x plus 7. We want to start every problem the same way, list out our excluded values. So those are going to be anything that would make any denominator be 0. So our left-hand denominator, we have x plus 1. So the value of x that would make that 0 is negative 1. For our right-hand side, we have a denominator of x plus 7, and the value of x that would make that 0 is negative 7. So we have two excluded values, negative 1 and negative 7. Looking for our least common denominator, that is going to come from factors of our factors of our two denominators being multiplied. So I'm going to multiply both sides by x plus 1 times x plus 7 over 1. And simplify as I go. So here I have factors of x plus 1 in my numerator and my denominator, so that leaves me with x plus 7 times x plus 3. On my right-hand side, I can cancel out my factors of x plus 7 in the numerator and denominator, and that leaves me with 15 times x plus 1. So on the left-hand side, I need to multiply my two binomials. So first I'll distribute my x. So x squared plus 3x. Then I'll distribute my 7. So plus 7x plus 21. On the right-hand side, I'm going to distribute my 15. 15x plus 15. On the left, I'm going to go ahead and combine my like terms. So that gives me x squared plus 10x plus 21 equals 15x plus 15. Now I notice here that I have a quadratic equation. So in order to solve a quadratic equation, I need one side of my equal sign to be 0. So I'm going to go ahead and move over my 15x and my 15 by subtracting both of them over to the left. So that's going to leave me with x squared minus 5x plus 6 equals, when everything cancels out over here, now I have 0. So here I can factor this or use whatever method of solving this quadratic that you are most comfortable with, but I do notice that this is going to factor to x minus 2 times x minus 3. Setting those separately equal to 0, I have x minus 2 equals 0 and x minus 3 equals 0, which gives me x equals 2 and x equals 3 as potential solutions. Now every time with our rational equations, we need to check those potential solutions against our excluded values. So in this equation, -1 was excluded as a solution, and -7 was excluded as a solution. So x equals 2 and 3 are safe. Alright guys, that does it for this video on solving rational equations. We'll catch you in the next one.